Okay, let's just give everyone a few seconds to jump in here. Get on board with the stream. All right, let's get this show on the road. Greetings, Houdini fans out there. It's Friday, it's 3 o'clock, and that means it's time for Houdini Secrets Live. My name is Chris, and I'll be your host for today. And today we're going to be continuing something that we started working on last week, and that is a little bit of an exploration with 18.5. Now, I promised you I was going to be going into the rigging basics of 18.5 Houdini this week, and it turns out I lied. And the reason why I lied is because I'm thinking like a rigger a la from the Maya world, right? Okay, now that's incorrect. I need to learn the new Houdini 18.5 paradigm. Now, it seems as if the Houdini 18.5 and the new Houdini KineFX tools are not quite ready for prime time, as would be from the perspective of a Maya rigger yet. So I don't think any of the Maya riggers are going to become defecting over into the Houdini world at any time soon. But with that said, I think what can be done really, really well is to take abstract motion taken from anywhere, from any character, bring it into Houdini, go ahead and then hook it up, throw some controls on it, and then edit that and edit with the motion as much as you like, and then write it out again. I think that's something that the Houdini KineFX is really potentially really, really good for. And that is what we're going to be going over today. And so if you're looking for the Maya equivalent of Houdini 18.5 KineFX, it ain't going to happen today. But I will show you some really, really cool stuff, and I think it will definitely be worth your while. So with that said, let's get this show on this road, and let's start going on. But first, before I jump into Houdini, I need to talk to you folks and give you some kind of like preparatory lecture. Of course, you knew I would have to lecture, didn't you? All right. So let's get going with this Houdini basic stuff. Now, this extends my disclaimer. I've already said the KineFX, in my humble opinion, is not quite ready for full art-driven character animation yet. It's very good for retargeting, though, clip editing, clip massaging, and procedural rigging. Now, I didn't go into procedural rigging today, and now that's something that could be explored into the future. I know that there are a couple of tutorials out there that do go into some procedural rigging, and they're really, really cool. However, this is not something I'm going to do. I'm going to stick with the character animation for the time being. All right, so like I said, they have a whole brand new paradigm for introducing rigging, and I am just learning it. So thank you for your patience dealing with my exploration into KineFX. All right, so the characters are now, instead of creating on the object level, you got to create your characters now on the SAP level. Okay, that's really cool. And so the advantage of that is that the characters can actually be brought in from anywhere. And that was part of my confusion in preparing for the lecture today. I was kind of treating it incorrectly. But I will show you today how to properly treat your characters in order to get them to behave with KineFX properly. All right, and so um, the characters, they can come from anywhere. They can come from the SOP level where you create them from stuff. They can come from the object level, whether you create them in Houdini or not. They can come from mocap. They can come from live streaming. Very cool, right? Okay. And the characters can be animated, edited, and altered, and so they can be nutted around with, and they can be you can add the animation or you can redirect them, but they're not really good for creating from scratch like now as if it was from Maya. Okay. All right. No more joints or no more bones. Well, technically not. There are no more joints. There are no more bones. Okay. Okay. Animation now. All the joints are now no longer joints. They are now points. They're points in the SOP level. Okay. They are points with a world transform. And you're probably going, well, gee, Chris, what is a world transform? Okay, that is a consisting of a position of the point and a 3 by 3 matrix. A 3 by 3 matrix is a matrix of a 3 by 3 matrix that is used to store the translation, the rotation, and the scale matrices. Now, if you don't know what I'm talking about when I talk about the translation, rotation, and scale matrices, check out I'll post it a little bit later inside of the channel or this description. I do have a TechArt Talk Live that talks over the transformations for matrix transformations, and they're the same transformations, and the information from that lecture are totally applicable to this situation. Uh-oh. Sounds like my voice might be getting picked up by 2 microphones. Well, that's not cool. All right. Well, thank you very much, Jason. I am going to go, oh, look at that. I'm going to go and get rid of one of these. Okay, hopefully this fixes the situation. I'm evidently only receiving microphone from one. All right, hopefully that's good. Jason, if this is still the same problem, please go ahead and document and right away either to fix the situation or not. All right, getting back, a point or a rig is now a series of points, and along with that point is a 3 by 3 matrix. Okay, a point may be considered a joint only when the transformations or the attributes, the transformation attributes are as a vector 9. Okay, it's got a name attribute. Okay, so that's when I can go, and let me go back to it. And so when you've got a position attribute and a name and a transform attribute, that's when you can be called a joint. All right, a skeleton then. In other words, what's a skeleton? A skeleton is also called a kinefx hierarchy. It's a collection of points. Okay, so there we go. It's a collection of points. Those are 3 points. And they're connected by polygonal lines. And so there is a potential parent-child hierarchy created by the order in which these points are generated. Okay, they're established by the vertex order. And the links are visualizations of that hierarchy, so they don't really represent something true hierarchy as in bones or in joints from Maya. Okay, so what about this whole points versus bones business? Okay, bones were problematic because bones have length, and then bones will only consider the local space translations. Okay, so that's what a limitation. Now we can take advantage of the translations, the rotations, and the scales. Okay, bones have fixed length orientation. That means because the character was set off and the offset is set by the z length, by the parent's length, you can't really change it. Well, that's all changed. You can change that now. All joints can be changed in scale. Bones don't scale. Okay, squashing and stretching dynamically was a bit challenge in the old paradigm. In the new paradigm, that is much different. Okay, now the definitions weren't bone driven, they were handled on the SOP level. And so that means that the character was being manipulated inside of the object level, but the deformations were being handled on the SOP level. And so that created a certain duality that was really kind of awkward. And the object level poses were attached to the skin, and that as soon as you futz with the bones, everything destroyed the skinning of the bones. Well, that's not the case anymore. Now with the new paradigm, you can futz with the bones and you can futz with the joints all that you want, and that won't affect the skinning. So that's actually kind of cool. All right, so I'm going to go and return and go to the Houdini demo and get things going from there. All right, bring this up. Where's my Houdini? There we go. Okay, so let's get this show on the road. Okay, I am going to return to the project that I started last week. And let's see, where's my project? Where's my project? Set projects. Okay, kinefx exploration. All right. Ooh, look at that. Here it is. the Houdini Secrets 25 1204 KinEffects Exploration. I'm going to open that up. Okay, there we go. Now we've got this good stuff. Now, if you haven't already, what we have to do is download Eric. And where you can find Eric, well, okay, let's go open up a thing. Okay, we don't want to look at Jupyter. You don't want to look at my AI experimentations, but we do want to look at side effects. So I go to sideeffects.com. Go ahead and log yourself in. I'm already logged in as good old Rudy Punk. Go over to support or get. Go to content library. And there is Eric. Go ahead and select Eric. Go ahead and then download this guy. Okay, now you can go ahead and unzip him. And I'm going to unzip him inside of my characters folder inside of my project. Now, if you don't have a new project, go ahead and create a new project with a characters folder and a clips folder. Okay, go ahead and unpack the Eric information. You've got an FBX and 2 PNG files. Go ahead and unfold those into the Eric folder here. And so with that said, we should be ready to rock and roll. All right, I've got a new session going here. We're all good. So I'm going to drop down a geometry node. And I'm going to call it Eric Rig. Got to drop inside of there. And now what I'd like to do is use an FBX character import. Okay, we are getting an error out of here, not a problem. It's because we don't have an FBX file selected. Go ahead and select the FBX file and click the job and go to characters. And then there's my Eric. Here's Eric version 1 FBX, accept. Okay, and there is Eric. All right, very cool. Now, there is an alternative to do this, but don't do the alternative. Do not use a file SOP to read in your character. Okay, the reason for that is because when you bring in an FBX character, it brings in the whole character, including the rig and all that stuff. Now, remember the old days when you used to bring in an FBX and it used to open up all those object nodes? Doesn't happen anymore. That is a thing of the past. What you do now is this is all stored inside of this FBX character node. Very, very cool. But if you open up a file, it will just read in the vertex or the point information, and you won't be able to work with all of the stuff that's been done for you. Okay, so let's take a look actually what's in this character, FBX character, because this actually explains a lot of how Houdini is going about representing its new character. So I'm going to open up a, well, let's go right here. I'm going to open up a new view or inspector. Give me a geometry. Okay, here is Eric's geometry. Notice that it's a little bit different in that it's got 3 different outputs. It's got a rest geometry, it's got a capture pose, and it's got an animated pose. Okay, now when it reads from the FBX, it does 2 different reads. It does one read where it gets the rest pose and the capture pose. Now that is needed in order to create all the skinning. Then it reads the FBX again for an animation pose. Now this animation pose is different. Now I'm going to go ahead and try to explain this. Now inside, let's take a look inside of the rest geometry. Inside of the rest geometry, you have the basic points, and you have their which bones they are captured and the weights that they are associated with. And so that's actually pretty straightforward. And I haven't quite had a chance to figure this out yet as how the points are actually weighted to the various bones, but they are, that's all that is stored here in the rest geometry. Now, if you go over to the vertices, you'll see that all the points do have normals and they have UV maps. Okay, so this is just straightforward mesh information, including the FBX base materials. And so it's reading in information and then it embeds, yes, it actually embeds an entire material network inside of that node. And then it creates a brand new material network based on that, and it reads in all of the FBX material information, translates that into a shop node, and now these primitives now access the information from that embedded principled shader. Cool, right? Now, if you look over here, there is some skinning information, which I don't really understand yet, but I will pass that information on to you as soon as I figure it out. Okay, so let's take a look at the capture pose. Now, the capture pose doesn't have any detailed information, but does have point information. And on the point information, it has all of the points that consist of the actual rig itself. Now, this doesn't have any mesh information. You'll notice that there's just 54 points, which means that there are 54 dots, and there is its information. It has a 9x9 transformation, and it has the name associated with the bone that it now represents. It also has color information. Now, here's what's interesting, is that the vertices now contain the vertex point count. So it's now point of certain polygons. You'll notice that now there are just 53 polygons in here, and the vertices carry forth that information. Now, what we could do here, in order to check you out here, I'm going to put up a null here in order to show this stuff off. So what we have here is this is just the mesh information. Now, if we were going to go look over here, this is the capture pose information, and we see here is our skeleton. Now, this is just 54 points sitting right in here, and it's just 55 points, I'm sorry, and 54 primitives. And that translates double that into 108 vertices. Now, here's the weird thing. You turn this over to the animated pose, and it doesn't seem like anything has changed, but quite the contrary is true. When we go into the spreadsheet, we'll notice, well, I kind of went through this yesterday, but the animation pose, the vertex order is now the exact opposite of what you thought it would be. And so where the capture pose has all the vertices listed in one order, the animation pose has all of the nodes or all the joints listed in the opposite order. And along with that is color information, name, and path information. And there's a scale inheritance if you want to do that. And there's the same 3x3 transformation. And so that constitutes what our rig pose is. And now I will be informing the curious Houdini folks over time in order to try to get more information going. But for the time being, that's kind of like what we're stuck with here. In order to get this thing working, what we're going to do here is drop down a bone deformation sub. Okay, now we have a character that is deformable. That's cool, I guess, but we can't do anything with it right now because the bone deform is expecting information coming from the animation pose in order to tell it to how to deform. Because right now, the animation pose is exactly what we are expecting it to be. And so in order to remedy that situation, we would insert a rig pose SOP. Now this rig pose SOP enables us to go and edit the character. So if we put the display on here and then hit the rig pose and then hit enter, There we see all of our joints here. Now, I haven't figured out how to show the display of the skeleton just as the skeleton, kind of like the way you would do it in Maya in a kind of an invisible node. But regardless, what you can do is you select each one of these new points, and now if you edit them, you can go ahead and change them, and then you can manipulate them. Now this behaves exactly like, oops, wrong node. Yeah, they've got these twist nodes that aren't hooked up there. Why? I do not know. That's weird. I did notice for the Eric rig that there are 4 extra joints in here that constitute for twist joints, maybe even 6 extra joints, but they don't do anything. They're not hooked up to the capture pose, which I haven't quite figured out yet, but more information on that as I figure it out. Now we can go ahead and manipulate that, which is fine. Now this rig now is fully animatable. Now we could go ahead, now this is strictly FK, mind you, there's no IK hooked up to it, but we could go ahead and animate this as normal. So if we wanted to just go ahead and bend old Eric here at the waist, what I'm going to do is, where's my spine? Is this my spine 01? I'm going to key my rotations here. And then I'm going to go over like frame 90. And then we're going to make Eric bend way over. He's looking there. Okay, then I'm going to go ahead and key those frames. And then I'm going to go over frame 180. And then I'm going to set those back to 0. And keyframe that. So now if we want, we could go ahead and animate this kind of like as expected. Piece of cake, right? Now this is cool because every rig pose then acts as a layer of animation. Now, if there was animation already put into the FBX, it would inherit that and then pass this on. And then now what we can do is edit this. So every time you want to create a new layer or some extra animation, toss in a new rig pose. And I'm going to go do that right now. I'm going to toss in a rig pose here. Okay, I'm going to click that, make sure that this is clicked. And now I have a brand new rig pose that is just ready to rock and roll. So I'm going to go and for frame 1, I'm going to grab my hip joint. I'm going to key this. Frame 90. Let's go ahead and rotate that. And out of the way. Yeah, I'm not going to get any Academy Awards for animations this year. Better not make the dream team. All right, can't make the dream team. I'm going to go ahead and key this and then go over frame 180 and put these back to 0. Let's go ahead, revert to defaults, and then key these. All right, cool. Now we see we have 2 different layers of animation going on at the same time. Now it is possible because each one of these layers can be turned on and off. I'm going to go ahead and like turn off the waist rotation. And so there's just the leg rotation. And here we can turn off the leg rotation. So we just have the rotation at the waist. Now notice that that other rig is still going, but if we turn this on here, things get really fast. Oops. I click into here, and there we see only the leg because the waist has been disengaged. All right, so there you have it. Multiple different poses with multiple different rig poses and multiple different animation levels and multiple different animation layers. So that's really cool. Oh, I'm just going to go ahead and delete that for the time being. I guess I won't need it now. So grabbing the controllers can be kind of awkward because when you press on this, all the actual nodes themselves, the controllers here, I don't really have it. So how would we go about creating a controller? Well, it's actually kind of simple. I'm going to go ahead and drop in just a circle. just a wee circle. And then I'm going to call this head underscore control underscore geo, because this is my head control geometry. I'm going to turn this into a polygon, and then my scale, I'm going to change this to 0.4. And there it is, just sitting like there in its glory. Okay, so I'm going to go ahead and give this head controller some color. So I'm going to drop in a color sop. And then I'm going to make it golden. You can make it any color as you want. And there it is, but we lost Eric, but that's okay. We're going to get him back. And now this is really, really important, is that once you have the control object, what you have to do is give it a name. Come on. Give me a name. Here we go. All right, we got a name here. Let me go ahead and turn that off. And now I'm going to leave that name as, but so all we need here is the actual name of the control, and I want it to correspond to the actual joint that I'm going to be manipulating. So I'm going to call this head underscore CNTRL. Okay, so this is now known as the head control. And notice now, all this is a primitive, and it has a primitive attribute with a name attribute, a primitive with a name attribute put onto it, which is called head control. All right, now what we have to do here is now we're going to append a attached control sop. Yes, that's what it's called. Oops, that's not what I wanted. Swing this over here. Create an attach control geometry. Okay, I'm going to hook that into here and then hook that into the rig pose. And if we display this, okay, we don't see it. Okay, we're not quite done yet. We still have stuff to do. All right, so for the transformation path, I want only the head joint to be manipulated. And so inside of the animation pose, each joint is associated with a name attribute. And so I'm going to say at name equals head. Nope. That is the bone deform, and I want to change the attached geo. Okay, I'm going to add one because we're going to create a controller here. So the group one here is at name equals head. All right, and now the control name is going to be coming from the second input, and we're going to call this head underscore CNTRL. Okay, we still don't see anything. And there's a reason for that. And in order to do that, in order to figure out what the reason for is, we're going to have to do a little bit of sleuthing. So let's go ahead, and I knew I should have, let's go into this FBX object here. Take a look at the character spreadsheet. I'm going to go over to the animated pose. Now, if we go and look over to the head joint, or actually look to the root joint. The root joint, look at its transform. It's 0.01000000. Oh, this is negative 0.01, 0.01, and ultimately 0. Okay, for those of you familiar with transformation matrices, you'll really realize that this transformation matrix has a scale matrix that is practically 0. In fact, it's 0.01. It's dinky. It's small. So in order to get around that, what we have to do is we need to go ahead and fix the scale on the object, on a control object. And I'm going to do that by just dropping in a, whoops. I'm going to do that by dropping in a transform. Plug that into here. And then I'm going to call it 100. Okay, so we do have that. So let's see if we're attaching anything. Okay, so there it is. So there is my head. But if we go ahead and click on the bone deform, display that, we still don't see it, but we can see the shape of that because we have the attach control, and we see that the shape is intersecting his head. So I'm going to adjust the head, but I don't want it to adjust here in the transform because the precedent of my transformation is to scale and then rotation and then translation. And I know that I want to keep it in the proper circle space, so I'm going to do my transformation here. And I'm just going to maneuver this by 0.25 in the Z direction. And so now when I go ahead and look onto here, my controller object has been displaced. If I click onto here, then we see it's like over his head. Now, if we wanted to go ahead and do any of these rig poses, there's our control object, and there is the manipulation for our head. So I can animate the head now as well. I'm going to go ahead and animate the head because I feel like animation. All right, let's do this. Let's make him look up. Said, kiss me, baby. Click over there, click that over here, and now let's put this back to defaults, and there we go. Okay. There it is. Okay, so that's pretty cool, right? So we can now attach controls to every one of our individual joints that we want. Okay, but folks, this is Houdini, right? And this is Houdini, and I said that we could do this procedurally. So let's not do this by hand. Let's go ahead and do this procedurally. And so what I want to do is I want to attach a controller on every one of these joints. All right, how will we go about doing that? Well, thank you for asking. So what I'm going to do is I'm going to pull this off, and then I'm going to lay down a null. I'm going to be using this for information for other purposes, but what I want is this to be attachment for my skeleton. So I know that my skeleton is put in right here, and I don't like the shape of that, so I'm going to change my color, make it yellow, and I'm going to change my shape, and I know this is just for information, so I'm going to make it kind of like oval shape. Okay, so there is my skeleton information. And now from this, I'm going to append a for each number situation. I'm going to change each of these titles to something a little bit more reasonable. So for my begin, I'm just going to call it begin. My end, I'm just going to call end. And my count, I'm just going to be calling it as count. All right, very cool. All right, so I'm going to go and change this. So I'm going to go change my begin, and where it says method fetch input, I'm going to change this to fetch feedback, because what we're going to do is we're going to be building all of the controllers, and we're going to merge them into one object here. And so let's go ahead and do that merge here. We're going to go to the end object. I'm going to change my language to Python. Uh-oh, watch out, folks. We're going to be doing some Python. And so for the iterations, okay, I'm going to make sure that that is toggle the, okay, edit expression. All right, so here is my expression. So I'm going to need my skeleton node. So who dot node, and inside I want dot slash skeleton. Okay, now from my skeleton, I want its geometry. So hey, node, skeleton node, give me your geometry. Now you're going to ask, why do I want that geometry? Because I want the points. So okay, once you've given me the geometry, then give me the points. Okay, so now I have all the points. And now what I want to do is identify how many points are there. So just exactly how many joints do I have to create for? And so we have all the points, and now we have to figure out how many points there are. And that's simply done with the length function in Python. Go ahead and hit apply. Okay, no problems here. And now if we look under here, it says that there are 62 joints. Okay, so that means we're going to be iterating through this loop 62 times. Okay, I'm going to do one more bit of preparation here. And now this is also a convenience function. I'm going to click over here on count. And then I'm going to do something snaky. I'm going to right click onto this and go into the parameters and channels menu. And I'm going to select edit parameter interface. And now I'm going to grab an integer. Integer, where's my integer? Ah, here we go. And I'm going to slap that underneath root. And then I'm going to call that iter. Now, I'm going to go ahead and apply and accept that. Now, the count node, as you can see, if we go into the geometry spreadsheet, does have information here for the iteration and so forth. But I found I like this way easy. But we have the iter here. So what I'm going to do is just go ahead and put an expression in here that makes things a little bit easy for me. Say detail. And then I'm going to say dot, meaning this. And I'm going to look for the iteration. And I want it to be the 0. Oh, I have to put that in quotes. Iteration. And then I want the 0th. Okay, click apply. Close. And then we say, okay, cool. We get the number of 61. So that means we've iterated 61 times. Well, actually, we've iterated 62, but that's just the current iteration number. All right, we're setting things up for success here. Okay, now let's go ahead and create the controls. And so we're going to create the controls by starting off with just dropping in a box. So drop down a box top. And then what I'm going to do is change the scale. I'm going to change that to 0.4. And then the Y, I'm going to make 0.25. And for the Z, I'm going to make 0.25. Okay, so what we have is a little bar here. Actually, I'm going to change that a little bit to maybe a little bit wider, so I'm going to call it 0.5. And so now we have is a bar here. So let's go ahead. We've got the box here. So let's go ahead and slap in a null sub. I'm going to toss in another null. Nope, not. Come on, behave for me. There you go, null. And likewise, since this information is going to be for, since this null is going to be for information purposes only, I'm going to change its color. And I'm going to change its shape to something, let's say, I'm going to change its name now. Oops, not to Z, I want to get rid of that. Oops. I've got Z, I'm going to call this one name. I'm going to make the name. Okay, so what's going to happen here is that this object here is going to store the name of the current joint that I'm working on. And so like I created another attribute here underneath count, I'm going to do the same thing for this joint, for this guy right here. I'm going to right click on this, choose my parameters and channels interface, go to edit parameter interface. I want to drop down this time a string, and then I'm going to call it name. I'm going to make the name here. All right, accept. Okay, there we go. There's my extra control. Now I am going to change my thing to Python, and so when working with this null sub and we put in a string, we kind of have to make sure that we're working with we want to edit the expression. So I'm going to right click on the name parameter, go to expression, and I don't want to edit the string, so I'm going to toggle the expression. I'm going to right click on it again. I'm going to click expression, and now I want to edit the expression. All right, there's my expression editor. Okay, so what we're going to do is we're going to get the information once again from our skeleton SOP. So I'm going to go who.node, and I'm going to get the skeleton information. So /skeleton. Okay, we've got my skeleton SOP here. We got that. Okay, give me skeleton SOP. Give me your geometry. And it gives me the geometry. Okay, then give me the points. Gives you the points. All right, now which point number do we want? Good question. We want whatever the number is currently being iterated on. And that information is being stored inside of the count object, the count SOP, if the iter parameter. And so I'm going to put in square brackets here so we can index the proper point. I'm going to go ch, and inside of that little string, I'm going to put /count / iter. That is going to control which point number I'm currently accessing. And if we take a look at this, if we hit apply, yeah, we get information, but it's going to be garbage information for the moment. I'm going to get over this. So what we want here is we know we've got it, but we need to get the name attribute from that point. Remember, every point has a name attribute, and it has a 3x3 matrix for all of its transformation. So we're going to get the string attribute name. We're going to go point or dot. We're going to get the string attrib value. And which one do we want? We want the name. Oh, okay. If we click accept here, we still are good. And this is geo1. So this is not the, okay, so this is not the right number. This is the last geo. And technically this is correct, but we want it to be, according to this one, it's always going to give us the last one. And so what we have to do is, oh, actually, this is actually going to work. You know what? I'm smoking crack. This will actually work, folks. Okay, let's see if this works. I'm going to come back here. If this doesn't work, we know where to go to, but I think this should work now. Now, so that's really cool. So that's that shows us. So let's, for giggles, let me just test this. I'm always testing. So I'll click over here to end, and I'm going to say, okay, go into single pass. And so now if this is 0, this is count 0. So what's my name? Root. Hey, it's working. Now if we change this to this first thing, then it should be like the pelvis or something. Yep, there it is. Okay, pelvis. Very cool. All right, so this is actually working the way we expected it to be now. All right, that's a relief because I hate to debug that expression. It's kind of a nasty expression. All right, now that we have our name information, we have the right name, let's give it an actual name SOP. Now, come on. All right, we've got the name SOP, and then all we're going to do is we're going to change the name over to Python. And then so what we're going to do is, let's see, do all we need here? Actually, we don't need to actually be Python. We can leave this H script if you want because it's the same command in both languages. So it's ch dot, and then in the quotes, it's // name / name. Okay. So now you understand why I do this. Okay. Now, it didn't pop up. Why didn't it pop up? Well, it's because I forgot to toggle the expression here. So I'm going to go ahead and X that out. I'm going to toggle the expression. Now I'm going to put it in here into the name. And now it's still not functioning. Why are you not functioning? Got to get rid of you. Right click on their expression. Toggle. Okay, edit expression. Now I'm going to go ahead, put that in here. Accept. All right, and now it equals 0. Channel name and name. Okay. Did I do this wrong? Maybe I'll have to keep this, put this as Python then. expression, edit the expression. Now that ch. Oh, I do need it to be Python. So even though this works, so it's Go1, so that's right, and this corresponds to Go1, and this is Go1, so that matches. We need this to have a prefix of control, actually, and not as a prefix, but as a postfix. So I'm going to go ahead and change this, and then I'm going to edit this expression. So I'm going to change things up around, and so I've got Python on my brain, so I'm going to go label this as quotes, and then inside brackets, underscore CNTRL. So this is going to be my control. And so if you don't know what this Python business is, CNTRL, let me explain. Okay, this string expression here is a template. And what I said, okay, give me some stuff, and then append that stuff with underscore CNTRL. Okay, so that it's control. And then when we have this format, we are going to control what kind of information goes into that little slot there. And that's where we put the name. So when we click apply here, now when we look at the name, it says Go1 control, which is exactly what we are looking for. Okay, now we know that we're going to have to scale this up because it's not going to be the right scale because we've got the root node in here is wacky and it is really, really small. So let's go ahead and put in a transform SOP. I'm going to drop that in there and I'm going to scale it up by 100 times. And so now it is really big, but it's not going to stay that way. We're going to change. All right, now we've done that, we're going to drop in a attach control geometry, and we're going to stick that thing right in there. Okay, we've got that working, and so what we're going to do is stick that right into here. And we don't see anything yet. And the reason for that is we haven't quite configured our attached geometry yet. Now, even though we have our beautiful, it's huge, our control object, we still have yet to attach it onto there. So let's go into there. And so since it's going to be iterated over, we're only going to add one control at a time. So I'm going to click a little plus here. And so there's only one control. I'm going to change the Python name over here. So for the group one name, I'm going to toggle the expression, and then I'm going to edit the expression. Now for this one, we want to be the expression here at name equals, and then we want the actual name. Okay, close quotes, dot format, and then we are going to get the information from our name SOP. So ch parentheses quotes dot slash name close parentheses, close quotes, close parentheses, and that should do and nope, we need one more. You wouldn't believe how many times I goofed up in my Python class about that. Okay, so now if we click on the group, we say name equals geo. Oh, we have to put an equals. Oh, yeah, okay, that's right. It equals, that's right. All right, cool. Now for the control name, we're going to do the same thing. We're going to go over here, toggle the expression here, edit the expression again. All right. So we're going to put quotes in here, and this is quote underscore C underscore CNTRL dot format, and then we're going to address the exact same channel information again. So inside quotes, I'm going to do CH. Now we're going to parentheses inside the quotes. Come on, get out of there. My audience can't see. Dot slash name. close quotes, close parentheses, and then terminate that. All right, click apply. And now we see the control name is the GO1 control. Click accept. Okay, we are ready to rock and roll. So does this actually show everything now? Aha, now we click that and look at that. All of the controls are now attached to the body. They're attached to the skeleton. Now they're not attached here, so what we're going to do here is we're going to pirate this, and what we're going to do is we're going to just attach this, and we're going to put that into the rig pose. And now when we take a look at any of these rig poses, if we want to edit it, here's our character, and we click that. Now this does take a while. When we create all these controls, this slows things down. But we do now see that we have controls on every one of our joints. Okay, cool you say, right? Okay, we're not quite done yet. Now we're not done yet because I'm still an artist, even though I'm a tech artist, and I really want this to be colorful. And so what I'm going to do is add in some color information here for every one of my boxes. I'm going to leave that out there just because it's not causing any problems. But all the colors are the same, and I want them to be rainbow colors, right? Okay. So I'm going to insert a SOP between the box and the name. I'm going to insert a color SOP. And then I'm going to change this over to Python. And I'm sorry to do this. Oh, this is important. Change the class over to primitive because we're not going to be dealing with the points. We're going to deal with the actual primitives. Now, what I'm going to do here is I'm going to edit the red, green, and blue channels. And I apologize, but I'm going to throw a wacky, horrible Python expression for you. I'll do my best to try to explain. I'm going to click on this and I say expression, edit the expression. And so now we're editing the blue or the red channel. And so with this, I'm going to write a little Python script. I'm going to go color equals who.color. Now this is important. Make sure that the C is a capital C because it won't recognize what a lowercase c is. Don't you love that? So what we're going to do is we are going to set the HSV. See, here's a tool tip for you. Whenever you're using rainbow colors, do not use random in the red, green, and blue. You get some pretty dingy, ugly looking colors that way. Why? It's because the intensities of these, when they go into random, tend to go into the dark areas, which tend to look kind of drab and muddy and kind of dingy. Instead, use HSV colors and then circulate on the actual hue. Leave the saturation and the value nice and vibrant. And so let's go ahead and do that. So color dot set HSV, and then we have to send it a tuple, one for the hue, so make this 1.0, one for the saturation, 1.0, and one for the value, which is 1.0. Okay, now let's just go ahead and return color. And here's the bad thing. You can't just return color and it's not going to return the RGB value. You have to tell it to return the RGB value. So it's RGB. And then since we're returning the value and we wanted to do just the red color, we have to do red. Okay, which is 0, which is red. Click apply and click accept. And everything is good. Now, if we look at our rig, okay, all the nodes are white. Okay, better, but we're still not done yet. So let's go ahead and crack open that expression that we have here. Nope, that's not what we want. Where is it? Cancel. I'm going to go to my color node. There it is. Now, oh, well, here's a problem. It's only on the red channel. It's got to be on the green and the blue channels as well. So let's go ahead and finish this. Now, notice that I wanted it to circulate on on the number of joints. So that means how many number of joints are. We want it to create a full spectrum from red all the way to red, going from the entire hue gamut. And we're going to do that by creating a little bit more of a sophisticated expression. So actually, let's call this red. Say red equals, and now this is a little bit complicated, so hang in with me, folks. So what we're going to do is first take 360, because there are 360 degrees in the hue scale, and then we're going to multiply that by the total number of iterations that we're going to have. So CH, we're going to multiply that by the current iteration that we're working on. So it's CH in parentheses and in quotes. We're going to go quote dot slash count slash iter. Okay, now we're multiplying the iteration number times 360. Now what we have to do is, once we've got that, then we're going to divide through by the total number of iterations. And that is stored over in the nsop, and there's the iterations value there. So we go ch, and inside quotes, we're going to go dot slash end slash iterations, close quotes, and that should be good. So let's just go ahead and replace this 1 by red. Well, actually, it's not red. We should actually call this hue. Okay, if you were Vietnamese, that wouldn't be hue, that would be Wei. I should know, I have a sister-in-law named Wei, and I've called her Hugh too many times, which is wrong because I have another sister-in-law who's also named as Hugh. I've got Hugh and Wei. So that creates lots of confusion when the white guy shows up. Ha, 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 ha. Okay, click apply here, and we have a syntax problem. Where's my syntax problem? All right, where's my unable to evaluate expression on line 4? Oh, Q, way, okay. We have one too many parentheses, one less parenthesis here, so it's a syntax error. Click apply. Yep, there we go. Okay, everything's cool, everything's copacetic here, and now of course it equals 1 here. So what I'm going to do is I'm going to copy this expression and accept this, and then I'm going to go over to the green channel, paste it into the green channel, and I'm going to scroll all the way down to the end here. And where it returns 0, I want it to return 1 for the green channel. And then I'm going to go all the way down here, paste this, and put this for 2 so I can get the blue channel. All right, so now when we look at this little spectrum, hey, there we go. We've got the full spectrum of color controllers. Yeehaw. Yeah, and actually, Ha is my wife's name. So she has sisters Hugh, Wei, Han. Let's see, it's Han, Hugh, Wei, Ha. Han, Hugh, Wei, Han, and Hung. Yep, that's it. Okay, they're all named with AHs. Okay, so then we click on that. And so now if we were to animate that, we would see now that we have the full animation, and now we have full controllers for all of our things. Now, it doesn't have the name associated with it, but it is pretty good controllers for it. And so that does a pretty decent job. Now, mind you, when you're displaying these poses, these rig poses get slowed down when you put lots of controllers on it. I don't know why. I'm going to have to talk to the Houdini folks of why that is that way. Do not know. So, but very curious situation. Okay, now, but if we click on it here, this slows things down. Okay, I don't know why things slows down. Like I said, going to have to talk to the Houdini folks about that. All right, cool. So there we have is our rig, and now what we can do is we can go ahead and manipulate and change and reanimate this animation layer by layer and create something brand new, and then export it again either to a game or to another destination, depending on how we want it. All right, cool. Now that's about all that I really was able to figure out for this week. I wanted to show you folks a lot more, but I wasn't able to figure it out in time in order to prepare for this lecture. So that's the way things exist. Sorry, gang. All right. Thank you very much for joining me today. And let me make sure that this here is visible. Dum, dum, dum. Okay, let me go ahead and fast forward this. All right, great. Now, if you liked what you saw today and you want more of this chutzpah, all right, so check me out at TechArt EDU. Now, if you liked what, go ahead and subscribe to this YouTube channel, and you'll get notifications whenever I create any new content, which is guaranteed to be once a week. All right, go ahead and check me out on techartedu.com. Now that has information about all the lectures. It has information about when there's information on all of the book information. Yes, there is the TechArt handbook coming out, and I am currently working on the real-time visual effects for technical artists, and expect that book out at the end of, or to the end part of 2021. Hopefully I'm working real hard. If you want to contribute images for this, I lost all my image makers because they were either deported or they decided to have career change and left the industry altogether. So I am in the market for people who want to contribute images to the book because I am running behind and I need help with these images. If you'd like to go ahead and contribute to the Tech Artist Handbook and the first installment, the real-time visual effects for technical artists, drop me a line. I can be persuaded. There might even be a copy of Houdini in there for you. Hint, hint, hint. Anyway, got to entice these people somehow. Check me out. I'm Chris Rhoda. Check me out on Facebook and on LinkedIn. Check me out on TechArt EDU. Check out Facebook and LinkedIn. And hey, hey, today we have the Houdini Users Group, 7 o'clock. Check us out and check us out on the meetup.org for the Orlando Houdini Users Group if you want to attend. Now, it's open to anybody, but you got to register. And today, since it's our last show of the year, what we're going to have is a show and tell where we're going to have all the members just showing off whatever projects that they're working on. Now, this is a non-judgmental, just a kind of a demonstration to show where everybody is currently residing and into the world of Houdini and showing off what they can and can't do. And it's all going to be good, and we're here to help each other and help each other grow, but we need to know where we are, who is working on the current stuff that we're interested in, and how we can actually start interchanging with each other. You know, actually make this a users group, right? Okay. All right. With that said, we've got the Houdini users group is on Facebook. Okay. Thank you very much. As said, that this is the last Houdini Secrets lecture of 2020. Next week is Christmas, and the following week is New Year's Day. And you're probably nursing a hangover then, so we aren't going to be thinking about Houdini anyway. Anyway, following, I think that's about the 8th, join me again on the 8th or the following Friday. And for the next installment of Houdini Secrets Live, I guess we're not ready to quite open things up to the FIA students yet. Once we go back to FIA, we're going to be showing off Vertex cache animation or the VAT stuff. Very, very cool stuff. But maybe if I have time, we can show more stuff that I've learned about the rigging for 18.5. Excellent. Thank you very much for joining me. Have a pleasant holidays. Have an awesome new year, and I'll see you in 2021. Bye.